Okay, circular motion here. Foundation of physics. This is the previous. Welcome. So there are some of the concepts that we are going to look at before we even go to the main concept, because these are the cornerstones of circular motion. All right. So let's say you have, all right, you have this type of arrangement where here you've got x, y, and x, right? Then let's say this is a line, a circular line, right? So you are moving from here. Let's call this as the first angle, angle 1, right? Then the final angle, let's call it angle F. So if you are going to move from A to B, that distance is what we call the arc length. And from the point here to any point on the circle, it's just called the radius. So if you do recall from your additional mathematics or from your normal mathematics, you would recall that this S is just equal to r theta, that's the arc length. But the theta, in this case, is S over r. And the theta is what we are calling the angular displacement. What we are calling the angular displacement. So as you move from A to B, you can see that there is a change in the angle. So that angular displacement is just a change in the angles. So this is what we call angularity displacement. Now, it's the same concept that you have always had under linear motion. The only thing that is now in angles and not really in those variables of x and y and so forth. Are we together, right? Next, we look at angular speed. This is a symbol, all right? Now you need to know that this is just the rate at which the angular displacement changes, right? Of course, we're saying the rate, this is with respect to time. Are we together, right? It's just the rate at which the angular displacement changes with time. So the rate of change, okay, with respect to what? Time. Now, we know that as it's a circular, so you have a circle like this. A complete circle is usually 2 pi, like 360, right? So you are going to take note that let's come here. If let's say if the angle on top there, like the total distance covered by an object is 2 pi, we call it 2 pi over t, right? This is just the same as 2 pi multiplied by 1 over t. Now, 2 pi, what is 1 over t? It's frequency from your secondary. This is just like 1 over period. T is a period, all right? So for an object that completes the entire circular path, it covers a distance of 2 pi, which is the angular displacement of 2 pi. Over time, 1 over t is frequency. So we can also define angular speed or velocity by that formula. All right, F is just the frequency. Then again, we've got the angular acceleration. Angular what? Acceleration. Again, angular acceleration is just the rate, all right? Now, we're talking about an object whose axis of rotation is actually fixed. So, the angular acceleration, that symbol there, of an object whose axis of rotation is fixed is just defined as the rate at which the angular speed changes with respect to time. Can you forget that? So we are saying it is the rate at which the angular, even the angular is going to have final and initial, but then you have got time with respect to time. All right? Now, before I even go anywhere, all right? What do you think are the units for angular velocity, or angular speed? What do you think are the units? So the units are rad per second. While for angular acceleration is, can you guess? Can you guess? Rad per second squared, or others they use revolutions per minute squared. All these are still units for angular acceleration. Now here is something that you need to know. Let's look at linear motion, and then we are going to put angular motion. So do you remember the equations of motion under linear? You remember them? The equations of motion? The first one that we have is, we know that velocity final, let me do this. We know that velocity is equal to u plus at. You remember this formula? What about in angular motion or in circular motion? How is it written? Now, velocity in our case will be represented by this. So, this is the final velocity. So here we're going to say F is equal to angular velocity, that plus, what is our acceleration? Our acceleration is this one, but time remains the same. What about this equation? We have v squared is equal to u squared plus 2as. So our v here is our final, all right, squared is equal to initial squared plus 2. A is acceleration, so it will be this. S is the displacement. What is our displacement in our case? Theta. What about this one? S is equal to ut plus half at squared. So this is our theta corresponds to our displacement, and this one corresponds to our initial speed plus half. Acceleration is actually that, and it will remain the same. So whatever you can do, you can just refer them to these, all right? So these are just a scenario. Okay, now what is the relationship between the angular, all right, quantities and the tangential quantities? So relationship between angular and tangential quantities, not components, but quantities. What is the relationship between the angular and the tangential quantities? Well, when a wheel, let's take for example a wheel of radius r, right, rotates about the axis, all right. Of course, here we're saying the axis of rotation is fixed. You will discover that there will be a point on the rim of a wheel, which is described in terms of what can I say? A distance L, we are calling the circumference, right? Which will keep on moving as that object keep on rotating that circular path. Now, each tangential speed v is always at some angle. Okay, so this is a circular path. Then an object is moving. All right. So it has got the speed it is moving with. We are calling the angular speed. But it also has got the tangential, the one which is just a tangent. You know the tangent, right? A line which touches part of a circle. So there will be a tangential speed called v, like from the linear part. So in short, we are saying what's the relationship between the linear and the angular? What equations relate them? So follow me. Now we know that S in our case, which is let me use L. Let's use L as a circumference. We said L, I gave a scenario to say from there to there. We call it length, which is the arc length. Let that one be L. We said it's equals to theta multiplied by the radius of the circular path, right? And okay, we said angular speed is what? The change in the distance, or in the angular displacement, we divide by the change in time. That's what we said, right? All right, now I want you to come very much closer. So this is angular what? Speed, right? Now what is this? We said this is just L over R, right? So if I say I replace this one with change in L over R, but I'm dividing again by the change in T, okay, what do we get? We get this is equal to change in L over R multiplied by what? 1 over change in T. But this is where now everything goes. So this is equal to, I can take out 1 over R here, that's fine. Then I can say the change in L goes there and the change in T goes there. So we end up having our angular velocity as, what is change in L over T? It's the same thing as distance over time. What is distance over time? It's velocity over R. So we are saying angular, the relationship between angular speed and the velocity itself is this relationship. So velocity is equal to angular speed multiplied by R. Done. Let's talk about angular acceleration. We said angular acceleration is just the rate of change of what? Angular speed over change in what? Time. But recall that angular speed is just is given by what? If you want, you can even use this one. It's fine. Okay, but I don't want that one. It's fine. You can use this one. Angular speed, we said it's V over R. So we can take it there. So we can do this. So you can put V over R, then we say multiply by change in what? In T. So what are we getting? We can take out 1 over R, then remains what? V over T. Now, let's go. 1 over R. What is velocity over time? Is actually acceleration. So we are saying angular acceleration is acceleration over R, in which acceleration is equal to angular acceleration itself times R. Just like that. These you need to know how to come up with them. So for this one, I think I've shown you how things are supposed to be done. The next time we meet, we are going to look at tutorials now.